Okay, this is the second half of lesson 8.4, unit 8, lesson 4. We just did double replacement reactions. We're going to carry on, and we're going to talk about aqueous solutions. An aqueous solution is typically water-based, and whenever you're dealing with a word problem and it says dissolved in water, water solution, or it just says the word solution, that's going to mean it's aqueous. An aqueous solution contains one or more substances called solutes. These are dissolved in water. When I was in school, it took me forever. I just have nightmares of it, of trying to differentiate solute and solvent. So I want to get you guys started right so we don't have to try to continually fix this. I want you to think of the Gulf of Mexico. Salt water, right? What is the majority of the salt water? Is it majority salt or majority water? Right. A solution is majority solvent. So if I were to actually talk about salt water, the water is the solvent. The salt is the solute. A solute is dissolved in a solvent. I got to be clear with you because I am having flashbacks where I can never tell the two apart. It took me forever. The solute is the thing that gets dissolved. The solvent is the thing that does the dissolving. If you have, you guys know those little tablets you can take if you want to boost your immune system? It's called Airborne. Y'all ever heard of that before? Or it could maybe like a little aspirin pill. And the pill dissolves in the water. And the pill is gone, but it's dissolved. That pill, whatever it was made of, is the solute. And the water is the solvent. Does anyone here drink coffee? You ever put sugar in your coffee? Does the sugar dissolve? So what's the solvent? The sugar or the coffee? The coffee is the solvent. The sugar is the solute. That's as plain as I can make it. So if you have a reaction that looks like this, aqueous hydrochloric acid, it can break down into aqueous hydrogen and aqueous chloride. Aqueous simply means that it was dissolved in a solution. So when you're looking at a word problem, if it says the words solution or water solution or dissolved in a solution, things like that means that it is aqueous. A solution is a combination of the two. So solute plus solvent equals solution. The Gulf of Mexico is a solution. It's salt water. It is a mix of salt and water. Is pure water a solution? No, it's just what would it be then if it's just water? S word. It's a solvent. Pure water is just a solvent. A solution means something was dissolved in it. Okay, next topic. Reactions that form precipitates. I believe this was on your vocab quiz yesterday. What state of matter is a precipitate? It is a solid. A precipitate is a solid. It's when you mix two liquids together and a solid actually forms. And it typically collects on the bottom of the container. So I'm going to give you an example of an equation that would form a precipitate. And the reason why they call it precipitate, like it falls to the bottom. If it was raining, if I wanted to sound really nerdy, I would say, hey guys, look, it's precipitating. No one says that, but that is an accurate statement. Rain or snow or hail is falling to the bottom. and it's a ground. When you mix two liquids together, and if a solid forms, it sinks to the bottom, and that's why it's called a precipitate. So here's an example of a equation that would form a precipitate. We have aqueous sodium hydroxide. We have aqueous copper 2 chloride. Oh, impress me. Why did I just call that copper 2? It has a positive 2 charge, Kellen. How do you know that? What is the charge of the chloride there? And how many chlorides are there? So it's overall -2. How many coppers are there? So what must the charge of that one copper be? And so what is the name of that copper? Bingo. That's how you know. If you didn't get that, I'm going to do that all again because that's really important. Kellen, let's do that back and forth. Let's speak up so the video can hear you. Kellen, what is the charge of just one chlorine or one chloride? -1. How many chlorines are there? 2. So what is -1 times 2? -2. How many coppers are there? 1. So what must the charge of that one copper be to balance out the 2 chlorines? And so what's the name of that copper? Copper 2. Nice. All right. There it is. There's your solid or your precipitate. Reactions can also produce liquids and gases, guys. So just like they can produce solids, they can produce liquids, they can produce gases, but those liquids and gases don't have a special name. If you have a reaction that produces a solid, that is called a precipitate. But the other two, liquid and gas, they don't have another alias or another special name. All right. Now we're getting to the last topic. A complete ionic equation. You are to separate every substance in a equation into its ions. There is an exception, however, guys. Only aqueous substances do not ionize solids, liquids, or gases. So we're going to do the problem that you just had up above. I'm going to rewrite it, and I'm going to teach you how to actually ionize it, okay? And make a complete ionic equation. All right. I'll give you guys a moment to catch up. We're going to ionize an entire reaction. And ionize means break it up into its ions. And you are only allowed to do this if it is in the aqueous state. That means it can dissolve in water. You do not ionize it if it is a solid, a liquid, or a gas. You just leave it alone. So your participation is more helpful for you than for me. Because if you say something wrong, I can catch it and I can help you out. So if you're just silent, I really can't help you. So I want to hear your voices. I want you to take a look at the first substance here. That is called sodium hydroxide. Is it aqueous? So can you break it up into two things? Yes, you can. Now, that 2 is a coefficient. Guys, that 2 applies to the sodium and the hydroxide. So if I were to break this up, how many sodiums would it break up into? 2. What is the charge of just one sodium? +1. Very good. And it is going to stay aqueous. And we're off. How many hydroxides were there in sodium hydroxide? There were 2. 2OH. You guys had to memorize OH. What is the charge of OH, hydroxide? -1, and it is aqueous. Okay? Now, I want to pause there and let that sink in for a moment. You just successfully ionized sodium hydroxide into sodium ions and hydroxide ions. We were only allowed to do that because it was in the aqueous state. I now want to let you guys give yourself an opportunity to try to ionize copper 2 chloride on your own. Yes, Kellen? When you ionize them, they do stay aqueous. They are not going to go to solid, liquid, or gas. So I want to give you guys an opportunity to see if you can. I know this is your first little baby step. Kellen told you that's copper 2. So see if you can break copper 2 chloride up into its individual ions for me. And if you mess up, you mess up. You learn that that's not right and you move on. I'll help you out. Give you about 20 more seconds. Don't be afraid to mess up. If you mess up, that's good. We can fix it. You raise your hand. 10. Okay. How many copper 2s were there? Connor, how many? Or yeah, 1. So you just write copper, and I said copper 2, so what is the charge of it? +2, and it is aqueous. Now, this is going to be a part where I bet some of you may have messed up, and that's fine. Learn from it. How many chlorines are there? So you don't write Cl2. You're ionizing it. So you're saying there are 2 chloride ions. If you wrote Cl2, that's not correct. And this is good that you're learning that now. You write that there are 2 chloride ions. Again, we are ionizing this. You now go to your product side. I want you to try to ionize sodium chloride on your own. I'll give you about 20 seconds. That is commonly called table salt. Okay. How many sodiums are there when you have 2 molecules or 2 compounds of sodium chloride? There are 2. What is the charge of sodium? +1. It stays aqueous. How many chlorides are there? 2. What's the charge of chloride? -1. There you go. Now, last one. Copper 2 hydroxide. Do you ionize it? Connor's violently shaking his head no back there. Why not? It's a solid. If it was solid, liquid, or gas, you don't do anything to it. You just bring it down. And ladies and gentlemen, this is called a complete ionic equation. Very good. Now we're going to move on to the next step. You're going to eliminate spectator ions. These are ions that they have no role in the equation, or in the reaction, I meant. How can you tell? They appear as reactants and products. So what I would like you to do is don't be too crazy crossing these out. I want you to still be able to see. I want you to find chemicals on the reactant side and the product side that both appear. So let's just take it one at a time. Do you see 2 ions of sodium on the product side? Yeah, so just put a little cross through it. Those are spectators. Okay, moving on. Do you see 2 ions of hydroxide on the product side? Now, you might be thinking, I don't know what to say because I see it right there. I'm asking you, do you see it as it appears like that? I'll rephrase it a little bit better. Do you see 2 ions of hydroxide as an aqueous state? Do you see that on the product side? No, you don't. So you leave that alone. Go to copper 2. Do you see aqueous copper 2 on the product side? No. Do you see 2 ions of aqueous chloride on the product side? Yes, cross that out. You have eliminated your spectators. And so that gets us to the last part, is your net ionic equation. Your net ionic equation is your equation, is the reaction after you've removed the spectator. So what I want you to do now is just bring down everything that you did not cross out. And you're done with that. So here's what you should have had. Couple questions for you guys. Question number 1. Is this equation balanced? Analyze it, scrutinize it. How many coppers are there on each side? Good. How many oxygens are there on each side? 2. How many hydrogens are there on each side? Great. Second question. What type of reaction does this look like? Like yesterday, we classified reactions. Is it a synthesis, combustion, decomposition, single replacement, or double replacement? What does it look like to you? This is a synthesis reaction. Great. And what type of substance did these 2 aqueous reactants form? A solid. So what do you call that? It formed a precipitate. Okay. I want to give you a chance to put your skills to the test now. This is a practice one. It is going to be, let's see. Here we go. Okay. Your job is to identify the complete ionic equation, eliminate these spectators, and have a net ionic equation. All right. So here I have my net ionic equation. We just went over it. What we're now going to do is we're going to eliminate the spectators. Do you see aqueous barium on the product side? Leave it alone. Do you see 2 ions of aqueous nitrate on the product side? Eliminate it. Do you see 2 ions of aqueous sodium on the product side? Eliminate it. And do you see an aqueous carbonate on the product side? No, so leave it be. And what you'll now do is write the net ionic equation. You basically write down everything that you didn't cancel out. So we have barium reacts with carbonate to form barium carbonate. You want another practice? I think you could use it. Now, I'm going to give you another practice, practice number 2. This one's going to form a liquid. Okay, here we go. Okay. Net ionic equation. Eliminate spectators. And write the, excuse me, not net, my bad, complete. Then you'll do the net. All right, I'll give you guys a few minutes to do that. We have 9. Okay. Hydrogen bromide breaks up into a hydrogen ion with a positive 1 charge and a bromide ion with a negative 1 charge. Sodium hydroxide breaks up into a sodium ion with a positive 1 charge and a hydroxide ion with a negative 1 charge. They will react to yield water, which is liquid. I leave that alone. And sodium bromide breaks up to a sodium ion with a positive 1 charge and a bromide ion with a negative 1 charge. There's the entire net, or I keep getting that mixed up, complete ionic equation. I am now going to eliminate the spectators. Do you guys see hydrogen ions on the product side? Nope. How about bromide ions? Oh, wait, I shouldn't X that out. Excuse me. Do you see bromide? Yeah, get rid of that. Do you see sodium ions? Yep. So you just write down whatever's left. Hydrogen and hydrogen and hydroxide makes water. We have time for one more practice problem. Here we go. Okay. You know the drill. Give me the complete ionic equation. Eliminate the spectators. And then give me the net ionic equation. I doubt you guys have these memorized, so you definitely need to refer to a periodic table. If you have it memorized, great. I mean, I'm not saying it's impossible. I doubt you have it memorized. Okay, bell's gonna ring, so I'm gonna get started. Okay, there it is. Do you see two aqueous hydrogen ions on the product side? No, leave it. How about two aqueous iodide ions? Cancel them out. Two aqueous lithium ions. Cancel them out. One aqueous sulfur ion, sulfide ion. Leave it. And what do you do with a gas? Leave it. So write your net. And it is balanced. All right, everyone. If you have any problems doing a review after you've exhausted your notes and resources, you know how to find me.